So let's take a look at a function, derivative of a function actually, 8x cubed plus 2x plus 3, and the question is to find the original function. So find f of x. That means I need to take the antiderivative, and I'm going to use the power rule in reverse. So that'll be 8x to the fourth over 4 plus 12x squared over 2 plus 3x, and don't forget your constant. Now I'm going to cancel the 8 and the 4, reduce that, and reduce this one, and that leaves me with f of x equals 2x to the fourth plus 6x squared plus 3x plus c. So when I take the antiderivative of a cubic, I get a quartic, in other words, a fourth power equation. Now in general, a fourth power equation has sort of this shape, and what we know is that it's going to be a quartic, but we don't know what its y-intercept is going to be, which means that we don't know where it is. It could be down here, or it could even be way up here. Okay? So without any more information, we are not sure which quartic we're talking about, but these initial conditions, these are called initial conditions, are the information that we can use to find out what that c is. So when x is 1, we know that the function is equal to 6. So I'm going to plug 1 in here everywhere I see a x, and that allows me to solve for c. So the 6's cancel, and I end up with c equals negative 5. So that means my original function was f of x equals 8x cubed. So, sorry, no, not 8x cubed, that was the derivative. 2x to the fourth plus 6x squared plus 3x minus 5. So it was it had a y-intercept of negative 5, so it would have been down there. Let's do a second example. This time I'm going to start with the second derivative, and I've introduced some functions that are not just a polynomial, so combinations of trig and exponential functions. And again, I want to find f of x, the original function. So I've got to go backwards. The first step is to take the antiderivative of the second, so that'll get going one step back, means I'm finding the first derivative. I love taking the antiderivative of e to the x, it's so easy. This one is a little bit more challenging. So what derivative would produce a sine x? Well, a cos x produces a negative sine x, but we've got a positive, so that means that we need actually a negative here to produce a positive. That one's a little bit tricky, and it's easy to make a mistake with those negatives and positives, but double check. If you take the derivative of this pink function, you should end up with that one right here. Remember your constant of integration. So again, we've got a family of curves, and we don't know what c is until we apply this initial condition. So when the derivative is equal to 2, when x is 0. Now cos of 0 is 1, e to the 0 is 1, so I've got 2 equals 3 minus 5 plus c. So 2 equals negative 2 plus c, so that means c equals 4. So in conclusion, for this first derivative, I've now got all the information I need to pinpoint which curve it is. It's got a y-intercept of 4. But it wants me to find the function, so I've got to go one more time, the same process. So taking the antiderivative of the first piece is easy. Second one is 5 sine x, because the derivative of sine is cos, plus 4x plus d. Notice I've taken d, I'm using a completely different label for that constant because I don't want it to be confused with this. So you want to make sure you use different constant letters here. In order to find out what d is, I'm going to apply this initial condition here. So the function is equal to 1. This is equal to 1 when x is 0. So plugging in x equals 0 everywhere, I get this is equal to 1 This is 0 and this is 0. So I end up with 1 equals 1 minus plus d. Sorry, that's a 3 here. It goes 3 plus d. So that means d equals negative 2. And my final answer then is the function equals 3e to the x plus, nope, that's not quite right, 3e to the x minus 5 sine x plus 4x minus 2. And I encourage you to take the derivative of this twice to double check to make sure you get this function up here.